the metabolic power tells us the amount of energy that the subject must utilize to perform a given exercise. However, the mechanical load, the mechanical work, is also a very important concept. We must here be very clear and say that the metabolic power measurements, the energy measurements, or be it as energy or be it as power, E the mass energy divided by time, has always the same sign, is always an amount of energy that the subject must spend from his own sources, body sources. On the contrary, the mechanical work can be positive or negative. I make a very simple instance. If I climb uphill, I do work against gravity. My muscles will produce energy to overcome the gravitational field. On the contrary, if I run or walk downhill, of course, it is the gravitational field that makes work on my body. And the muscle must always spend energy, with the same sign as before, of course, but to reduce the velocity with which the work is pulling the body downhill. So the situation is rather different because, as mentioned before, the energy expenditure, the power expenditure has always the same sign. The mechanical work done can be done by the subject on the environment to going uphill or to accelerate the body, the kinetic energy of the body, or can be, on the contrary, done by the environment on the body, as when the subject goes downhill or when he decelerates, and in this case he must reduce his kinetic energy. This is a very important concept because the muscle is a much more efficient machine in absorbing energy than in producing energy. Let's make again an example of walking or running up a flight of stairs and then coming down this same flight of stairs at exactly the same speed. The amount of mechanical work and mechanical power will be exactly the same. Only the sign will change, because when the subject runs upstairs, he must produce energy. When the subject runs downstairs at exactly at the same velocity, he will have to brake, he will have to spend energy, his muscle will have to spend energy to avoid himself breaking his neck. And the muscles are much more efficient in braking, reducing the speed, in absorbing the energy of the eccentric contraction. They are also defined as concentric contraction when the muscle stretches and produces work, as compared to eccentric contraction when this muscle is lengthened, forcibly lengthened, and must absorb energy. Because the efficiency of absorbing energy, in the mest when running or walking downhill, is about 5 times better than that of producing energy, mechanical energy, as when the muscle has to shorten. So what happens when I walk upstairs at a given speed? I must use, let's say, 10 muscle fibers to produce this amount of work. When I come down at the same speed, only 1/5 of the same 10 will be needed. And as a consequence, the metabolic energy that I have to spend will be also reduced proportionately. As we know, it's always much less energy consuming walking downhill than uphill. But the other side of the coin is that the forces exerted on the contracting muscles will be exerted on only 2 fibers when I walk downhill, rather than on 10 when I walk uphill. And as a consequence, the force per active muscle units will be much larger when I walk downhill. And as a consequence, the situation of running and walking downhill will be much more convenient from the point of view of energetic, but much more dangerous in terms of possible mechanical lesions of the tendons, of the muscles, and of the joints.